Today we'll be factoring polynomials completely. If you look at this flowchart, you will notice the first thing that you must do is have the polynomial in standard form. Once you have the polynomial in standard form, then factoring should be pretty easy. You have to take out the GCF. GCF means the greatest common factor. That also means you have to look for the common number, common letter, with the lowest exponent. So, here are two examples that might help you. The first one's going to be x to the third plus 2x squared minus 3x. So over here, looking at this problem, we do not have a common number. We have 1, 2, and negative 3. But we do have a common letter. The common letter would be x. X times what will give me x to the third? X squared. X times what will give me 2? That would be a 2. X times x gives me x squared. X times a negative 3 will finish the problem. That's factoring out the GCF. Another example is going to be on this side. If I put in 2x to the fourth plus 12x to the third plus 18x squared, you will notice in this problem that we do have a common letter and a common number. So here our common number would be a 2. So if I factor out a 2, the common letter is x, and our lowest exponent would be squared. The common number is 2 is because 2 goes into 2, 2 goes into 12, and 2 goes into 18. So if I factor out a 2 from a 2, I get a 1. X squared from x to the fourth gives me x squared. If I multiply these two, I will get what I began with. 2 into 12 is a 6. When I take away 2 x's, I'm left with 1. 2 goes into 18 9 times. When I take away the x squared, I don't have 1. Okay, so that's how we factor out a GCF. From that point, I then stop and I look to see how many terms I have. For both of these problems, if you notice, I have 3 terms. When we factor a trinomial, we factor trinomials just like we did last night. So that means over here I look to see blank plus blank equals the b value, which was 2. Blank times blank equals the c value, which is negative 3. By filling in my blanks, you will see that I get negative 1 and negative 3. So I'm going to put in a negative 1 and a positive 3. That adds up to 2. Negative 1 times 3 gives me the negative 3. So when I get done, my answer is x minus 1, and x plus 3. And you'll notice that I have 3 factors because I have x to the third. So let's go over to this problem over here. It's a trinomial, and this time I'm going to do it using the x factor like we did last night. And this is going to be 6 on top because that's where we're adding. 9 on the bottom because that's where our c value goes, and that's where we're multiplying. If you notice for this problem, a 3 and a 3 will add up to give me 6 and multiply to give me 9. So I'm going to bring down my GCF all the way down. So this is 2x squared. Then I have x plus 3 and x plus 3 again. Okay. So now that we've looked at trinomials, let's look at if we have 2 terms. So if I come over here and just reminding you how to do this, this is called difference of 2 squares. This one was real simple. If I square root this number, I get x. If I square root 25, I get 5. And it's plus or minus. Again, x squared minus 16. If I square x squared, or excuse me, square root, I get x. The radical of 16 gives me 4, and it's positive and negative 4. Now we can do this even if we have a leading coefficient. So 4x squared minus 25. That's going to give me, remember, I'm looking for the square root of the first term. So if I square root 4, I get a 2. Square root x squared, I get x. If you notice, both of those multiply and give me 4x squared. Negative 25. I need 5 and 5. One's positive, one's negative. The only thing you cannot do is if you have x squared plus 36, all of these have minus signs because it's the word difference. That means minus. Okay? But since I have this positive in the middle, it's not factorable. So remember that when you're looking for difference of two squares. Okay, so what happens when we have 4 terms? When you have 4 terms, you have to look at it a little bit different. Okay, so the first one we're going to do is x to the third plus 5x squared minus 8x minus 40. So our steps here, since it says factor by grouping, I'm going to group first 2 terms and last 2 terms. So you group them by just putting parentheses around them. That's all we're doing. Then we're going to take, if I ignore this parentheses, you'll notice I have a binomial and I have a GCF. So I'm going to take the GCF of the first parentheses, which is going to be x squared, because I'm going back to the fact that I have a common letter and the lowest exponent is x squared. When I do that, I'm going to have x plus 5 left over. Then I'm going to look at the GCF of the second parentheses. Negative 8, x, and negative 40. Since I said the negative twice, the negative has got to come out. 8 goes into 40, so it's negative 8. So this is going to leave me with x and then a plus 5, because a negative 8 times a positive 5 gives me the negative 40. Now, I'm going to do something because I want you to notice that both of these parentheses match. If both of these parentheses match, I did it correctly. If they did not, you messed up. Go back and relook at how you factored out your GCFs. Now, since both of these now match, that's my new GCF. So here's my first factor. That came out because I have those 2 in common. Now I'm going to write what's left over, which is x squared minus 8. So again, the last thing that we do is you write what's common first, and then what's left over. Okay, so let's do one more just to make sure that you guys have an understanding of this. So this is x squared plus 9x minus xy minus 9y. Again, group the first 2, group the last 2. What's common about the first one is that I have an x. When I pull out an x, I'm left with x plus 9. I have negative x, y, and negative 9y. This time I said the negative twice and I said the y twice. So what's left over is x plus 9. And you guys may ask why plus 9, because a negative times a positive is going to give me the negative 9y. I'm going to circle the 2 parentheses, make sure that they match. Since they both match, that's what I'm writing first. Then I just turn around and write whatever is left over. And that's how you factor polynomials completely.